Hello everyone, today I'll be presenting our paper, Modeling Infants Free Play Using Hidden Markov Models. Our goal was to test whether hidden Markov models can reveal meaningful hidden structures in infant behavior. In this work, we want to understand more about infants' exploration patterns in a novel setting. When dropped into a new environment, infants usually explore different options before paying attention to a favorite toy. Specifically in this work, we are interested in what drives the infants to select the next toy they play with, how frequent they switch from one toy to another, the differences and the similarities between the current and the previous set of toys the infants play with. To this end, we observed 20 15-month-old infants, and each infant play in a room with 6 toys and a stationary caregiver in a novel lab setting for 20 minutes. Focusing on the infant's toy selection behavior, we collect the data on infants' moment-to-moment interaction with the toys and the caregiver. Here is an example of an infant's play session. The x-axis shows the 20-minute timeline of the whole section. The y-axis shows the toys in the room with each toy on a line. For each horizontal line, the color segment shows the infant interaction with the toy on the left during the duration. In this section, this infant shows two different playing states. The first one is shown through a high number of switches from one toy to another and the high rate of toy per minute. The second state is when the infant focuses solely on the broom, which shows through a lower number of toy per minute and toy switches per minute. From this motivating example, we will want a model that can learn these different play states as well as its transition between display states. Traditionally, developmental scientists quantify infants' behaviors using group statistics. This approach does not explore the richness in difference among infants and the temporal changes within single infant's play session. In this work, we aim to explore the individual variability in this infant population, as well as the temporal structure in each infant's play session. And to that end, we employ a classic state model, the hidden Markov model. On a high level, the hidden Markov model can be described as, at any given time, we assume that the infant is in a play state. For instance, we assume the infant is in state S1 at the beginning of this play session. Although we cannot directly observe the state is manifested through different observable features. For instance, how frequent they switch from one toy to another, how many toys they play within a fixed duration of time, and whether they play with the recent toy or they just revisit one toy that they have been playing for a while. When the infant moves on to the next play state, the only influencing factor here is the previous play state. And each new play state will generate a new set of observable features as we described. Our goal here is to learn the state sequence for each infant's play session. To apply the hidden Markov model, we compute features that can later help us to interpret the meaning of the state and do not depend on the toy identities. We divided the play session into non-overlapping intervals of 2 minutes and then calculate the number of toy switches, number of toys, and the number of new toys that they can play during these 2 minutes intervals. A new toy here is defined as a toy that has not been played with for the last 2 minutes. We'll focus on these 3 out of the 5 features, and we'll refer everyone to our paper to learn more about the full set of features. After turning each play section into a matrix of 10 by 5, we use Welsh algorithm with data from all 20 infants to learn the measurement parameters. For details on selecting the number of states, as well as other technical details, we will refer everyone to the paper. After fitting the data into a 5-state hidden Markov model, we identify two different types of states from the semantic interpretation: the 3 focus states and the 2 exploration states. The first focus state, we call it focus 1 or F1, is the highly focused play state. In this state, infants focus on a single favorite toy characterized by the number of toy switches and number of toy counts always equal to 1 or 0. The second focus state, state F2, is where the infant focus on 2 toys, with one being the favorite toy, which is shown by high favorite toy ratio, and then the infants mostly focus on the favorite toy, but then periodically shifted to the other toy as well. On the other extreme, we have the explore high or E plus state. It's the most exploratory state with a high probability of a large toy set, frequent switching, and more new toys than the other focus states. The last two states are the least focus set, and the low exploratory state, E minus. In focus set, infants switch among a relatively fixed set of toys. Explore low or E minus typically entails less toy switching, smaller toy counts, and fewer new toys compared to E plus. It's similar to the focus state F set, but introduces more new toys, which indicates it's more novelty seeking than F set. Here, we'll look at the initial state distribution. Exploration states had the highest state probabilities, whereas F1, the most focused state, has the smallest initial state probability, indicating that infants tend to start in more exploratory or less focused states. Put another way, when infants encounter a new environment, they tend to investigate what's there first before engaging in focused play. And at the group level, transitions from the exploration state to F2 or F set are more frequent than transition to state focus 1. Rather, the primary path to enter the most focused state F1 is to either start there at the beginning of the session or transition there from F2. This finding indicates a tendency to gradually increase focus in toy section, rather than going directly from high exploration to high focus. Moreover, the cell transitioning probabilities increase with increased focus, indicating that after infants are in a focus state, they tend to remain there longer than when they in an exploration state. In the interest of time, we will refer interested readers to read our paper for more technical details as well as more results on the model parameters. We now consider how the infer states are distributed over a play session. For each infant, we consider the most likely state for each of the 2-minute intervals. This figure shows how the number of infants in the explore states, that is E plus and E minus, and the focus states, that is F focus 1, focus 2, and F set, change during the play session. In agreement with the HMM initial state distribution, initially most infants were in the explore states. However, the number of infants in the explore states rapidly decreased and fluctuated until only a handful were in the explore states in the end. Interestingly, most infants were in focus states at the end and throughout the whole session. We also investigated how locomotion relates to the infer state of the HMM. So this figure shows the average distance in centimeter per second for each state across all 20 infants. Most significant difference is that infants in the most focused state, focus 1, travel substantially less, about 50% compared to other states, suggesting that infants who focus on one or no toy tends to be more stationary. In summary, in this work, we provided an interpretable model for toy selection that provides insights into moment-to-moment infant behavior by using a hidden Markov model. We also find trends of the playset over time, as well as the correlation between the playset and locomotion. In the future, we'll try to use more expressive models, for instance, by cooperating structure prior or by handling time continuously, and then hopefully we can use this state to inform exploration strategies from the RL agents. We also hope that this work pave the way to use more state model and time series model in developmental science. We also thank everyone for listening to this presentation.